everybody, today we're going to talk about linear inequalities and absolute value inequalities. So to start us off, we should talk about the types of inequalities that we have. We have greater than or equal to, less than or equal to. And as we go to write them, we're going to have interval notation and graphing that we need to work with. A lot of times when you're looking at graphing, you will see open circles or parentheses that go along with the graph, and with interval notation, you'll see different kinds of parentheses or brackets. So let's talk about each type. With greater than, you are going to see an open circle or a parenthesis, so think you have open intervals on both sides of the interval notation. Greater than or equal to will have a square bracket on the left and then an open interval on the right. You should expect to see a closed circle on a graph or maybe a square bracket to show that it is including the endpoint. Less than is going to be an open circle or a parenthesis when you graph it, and both open parentheses when you look at the interval notation. And then less than or equal to will either be a closed circle on the graph or a square bracket pointing to the left. And then when you look at it in an interval notation, will be a square bracket on the left and an open parenthesis on the right. So hopefully here and there are a lot of different ways to express inequalities. So we can graph them on a number line, we can write them in interval notation, and we can also use set builder notation. So let's look at some examples to show you how we would write them. So let's start with x is greater than 3. I'm going to start by graphing it on the real number line. So greater than 3, I'm going to go to 3, open circle, and then I'm going to go to the right, so I will kind of shade that in. As an interval, I have an open parenthesis, I have 3, comma, infinity. In set builder notation, I would write the set of all x such that x is greater than 3. If I had x is less than or equal to -2, this time because it is inclusive and it has an equality, I am going to make a closed circle at -2. I am going to shade to the left, which means my interval is -infinity to -2, close bracket. Set builder, I have the set of all x such that x is less than or equal to -2. If I have -1 is less than or equal to x, which is less than or equal to 4, I am going to have a closed dot at -1, I will have a closed dot at 4, and then I will shade everything between those 2 points. As an interval, it's a square bracket at -1 and a square bracket at 4. Set builder, I write the set of all x such that x is greater than or equal to -1 and less than or equal to 4. So let's change this around and let's write the interval notation for a graph. So for this graph, I see an open circle at -8, so I write -8. With a parenthesis. I see a closed circle at 2, so at 2 I write a square bracket. The next one I see is less than 4, so I want to write -infinity until 4, and because the circle is open, I do an open parenthesis. Then I see a second interval starting at 10, it goes to infinity. I want to do a closed bracket at 10 because there's a closed dot, and I put a union in between to say I have 2 separate intervals that don't touch. When we solve linear inequalities, we solve them the same way we solve linear equations, except if you multiply or divide by a negative number, you need to then flip the inequality, so I reverse it. For an easy example, if I had -2x is less than 10, when I divide by -2, I'm going to flip it to x being greater than -5. So when I divide or multiply by a negative, I flip the inequality sign. So let's solve a few inequalities and write our answer in interval notation. Let's start with 4x minus 7 is less than or equal to 9. I'll first add 7 to both sides. That gives me 4x is less than or equal to 16. I divide by 4. 4 is positive, so I do not flip the inequality sign. Now I have x is less than or equal to 4. My answer is -infinity to 4, close bracket. The next one says -2x plus 3 is greater than x minus 5. Let's subtract 3 from both sides. I have -2x is greater than x minus 8. Then I subtract x. I have -3x is greater than -8. When I divide by -3, I need to remember to flip the sign, so now x is less than -8 over -3 is 8 over 3. When I write this in interval notation, I say -infinity to 8 over 3, both open parentheses. A little bit bigger. This time I have 5 times x minus 4 is greater than or equal to 7 times x plus 3 minus 9. So I start by multiplying 5. I have 5x minus 20 is greater than or equal to 7x plus 21 minus 9. That is 5x minus 20 is greater than or equal to 7x plus 12. I'm going to move the 20 to the other side. So now 5x is greater than or equal to 7x plus 32. Subtract 7x from both sides. I have negative 2x is greater than or equal to 32. I want to divide by negative 2, and remember that when I divide by a negative, I flip the sign of the inequality, so now I have x is less than or equal to negative 16. So my answer is negative infinity to negative 16 close brackets. So you might find that as you're doing homework that you come across problems that you're asked to graph. When you're graphing, then I want to show you how to use the tool. Now take this problem, negative 9x plus 1 is greater than or equal to negative 26. I would move the 1 over, so I have negative 9x is greater than or equal to negative 27. I would divide by negative 9, which would make x less than or equal to 3. So because it's less than or equal to, I want to do a closed dot at 3. And to show less than or equal to, I'm going to hit this arrow and I'm going to move it to the left to show that it's less than or equal to 3. Then you're going to be asked to write this in interval notation. So I'm going to click in the box. I'm going to use a parenthesis. I'm going to say negative infinity, comma 3, and then I want to use a closed bracket for my answer. So as an extension of our talk on inequalities, let's talk about absolute value inequalities. If I have the absolute value of x is less than a, then I know that x is greater than negative a and less than a. If I have the absolute value of x is less than or equal to a, then x is going to be greater than or equal to negative a and less than or equal to a. So let's say I had the absolute value of x is less than or equal to 3. Then that means that x is going to be greater than or equal to negative 3 and less than or equal to 3. We could write that as negative 3 to 3 as an interval. Very similar, if the absolute value of x is greater than or equal to a, then x is greater than or equal to a, or x is less than or equal to negative a. So say I have the absolute value of x is greater than or equal to 7. Then I'm going to have x is greater than or equal to 7, or x is less than or equal to negative 7. So I have two separate inequalities this time. I have 7 to infinity, and I have negative infinity to negative 7. We end up writing this as negative infinity to negative 7, union 7 to infinity. Let's make that a little bit bigger. I have the absolute value of x plus 6 is greater than 4. That says x plus 6 is greater than 4, or x plus 6 is less than negative 4. We'll solve those separately. So first subtract 6. I have x is greater than negative 2, or subtract 6, x is less than negative 10. So I'm going to write negative infinity to negative 10, union negative 2 to infinity. The next one says the absolute value of x minus 5 plus 7 is less than 9. Before I split my inequality, I want to simplify. So I'm going to subtract 7. I have the absolute value of x plus 5 is less than 2. Because it's less than, I put it between negative 2 and 2. So I have x plus 5 is greater than negative 2 and less than 2. I'm going to subtract 5 everywhere. Negative 2 minus 5 is negative 7, less than x. 2 minus 5 is negative 3. So I have negative 7 to negative 3 as my interval. The next one says the absolute value of x minus 8 over 3 is less than or equal to 7. So I'm going to write negative 7 is less than or equal to x minus 8 over 3, which is less than or equal to 7. I'm going to multiply everything by 3. So 3 times negative 7 is negative 21, less than or equal to x minus 8, which is less than or equal to 21. I'm going to add 8 everywhere. Negative 21 plus 8 is negative 13, less than or equal to x, which is less than or equal to 29. So I have a square bracket, negative 13, and a square bracket at 29. Let's take an application. A company makes a profit when it brings in more money than it pays out. Suppose the company's revenue, the amount they brought in, can be modeled by R equals 220x, and its cost, which is the amount they paid out, can be modeled by C equals 200x plus 29,400, where x is the number of items sold. How many items must the company sell for the company to make a profit? Write the answer in interval notation. So the company makes a profit when the revenue is greater than the cost. So we're going to say 220x is greater than 200x plus 29,400. We're going to subtract 200x from both sides, which gives us 20x is greater than 29,400. We want to divide by 20, which gives us x is greater than 1,470. As an interval, I write 1,470 to infinity. So I hope that you can see that there is a very big similarity between working with equations or working with inequalities, but the big difference is we have infinitely many solutions to inequalities, and we usually only have one solution for an equation.